So who here knows about TUF? Knows something about TUF? Wow. Okay. So you are the only person who didn't at least do a hand waggle. Okay, that's great. That's great. So this talk will be mostly directed to you because this is the introductory session. Great. I'm glad to hear that. So I would imagine that most of you are using TUF. In fact, I'd imagine everyone in this room who's deploying things is using TUF, whether you know it or not. But anyway, let me not steal, some of the exciting things that are going to be 20 minutes into the talk, and instead, I'll get started. So I'm giving a talk here with Marina. She's a PhD student of mine. I'm Justin Cappos. I'm a professor at NYU. She's a student at NYU. And I'm going to be talking a bit about TUF and how it works and doing an introduction, and then I'll hand off to Marina a little later in the conversation to bring us home. So first of all, as I told you, I am a professor, and professors love to give pop quizzes, right? So I have a pop quiz for this audience. So what do these organizations all have in common? What do they share? Anybody want to shout something out? They're tech companies. They provide software. They don't all use TUF yet. They release software, yes. They all actually, I think if you had to pick companies that have good security teams, you would name many of these organizations. And they all actually have had their users attacked via some issue with software updates. So there are, if organizations that are among kind of the tech leaders building software we all rely on are all getting hacked in this way, and publicly that's known about, you can just imagine how prevalent this problem is. So repository compromises have massive impact. These are actually a really scary sort of scenario to find yourself in. Because what happens is that if someone goes and breaks in and, for instance, breaks into a repository that's serving like a bunch of open source software like Apache and other things like that, you can imagine that you can have an enormous number of users potentially be compromised. There's been lots of instances where this has actually happened. So when the best hackers in the world, where I would argue the best hackers in the world are a lot of the nation state actors, the people that go and are doing things inside major governments of the world and cultivating and building those skills and acquiring cyber weapons and attacking. So we have a situation where some hackers, allegedly the United States and allegedly Israel, hacked into Iran for the purposes of gathering reconnaissance and damaging centrifuges. And they did this by two pieces of malware. One was called Flame, the other was called Stuxnet. Stuxnet's the one that got a lot of the press because it was the thing that actually caused the centrifuges to malfunction. But it was a very simple piece of malware compared to Flame. Flame was a piece of malware that was actually spread via a couple of different issues and design flaws in Windows Update, including some of those that we talked to Microsoft about before Flame hit. Also, South Korea was hit by an attack allegedly by North Korea that caused over $750 million in damage to their economy. And we saw this like NotPetya MEDOC hack that you guys saw recently where it was allegedly Russia attacking Ukraine, but then that spilled over and hit a whole bunch of hospitals and businesses all around the world. So this is a big problem. Okay, so in the threat model, and the thing that TUF is concerned about and TUF worries about is we want to be worried about situations where attackers can do a variety of attacks. So, of course, they can do a man in the middle, monkey in the middle, whatever you want to call it, sort of attack. But they can also do some very serious things. Like we're assuming that attackers can break in and steal signing keys. They can break into repositories. They can break into servers. They can bribe somebody working for a company or do other things like this. So this is really meant to provide you the best possible protection you can have in these cases. And if one of the main takeaways here is that in practice, you're never going to be able to completely prevent there from being a compromise. So instead, what you want to do is you want to limit the impact. So make it hard for compromises to happen, but then make it so even when they do happen, it's not a fatal kind of world-ending event when it occurs. Okay, and just because it's helpful sometimes for some people, especially if they want to kind of make this case to their, to their boss or somebody, like, hey, why do we need this? Like, why can't we use GPG or whatever else? So first off, we look, when you go to produce information, like software that you want to have installed, you produce something that we can call an image, like a software image. This could be a package, this could be whatever it is for the specific type of system that you're trying to install. And there's also metadata that you produce that talks about this thing that it is that you want to go and provide. And so there's a few different ways to try to protect this information. Some people, in some situations, they'll go and they'll have certain types of online keys. Like, for instance, you'll have a server that people are communicating with using TLS, and you go and you do the whole X509 dance and all that other stuff, and you end up, talking to a party that possesses a certain key. And maybe you even keep that key in some cases inside something like an HSM. So the HSM is on a server. Or the other way of doing it is that you have some like offline devices where you often will usually just have a separate hardware token that only occasionally gets plugged in when you need to do an action. And one instance that we use a lot and is I think pretty common is to use something like YubiKeys or whatever like this, but different organizations have different ways of going and providing this. And so there's a big problem if you have this kind of online key, whether it's something like an HSM that maybe you keep in your build server that does signing of things automatically, or whether you have a repository where in the, where your repository just has parties communicating to it over TLS. And the problem is that if someone goes and compromises this system, even if you have something like an HSM, maybe they can't go and take the key off of the server that the key is on, but they can certainly sign whatever the heck they want with it. And that really defeats the purpose, because if the attacker can go and cause you to sign malicious copies of OpenSSH, as happened when an attacker broke into the infrastructure for Fedora, then you obviously have a big problem. Your HSM hasn't really helped you in any way. Okay, so yeah, so you have this problem. So the real message, like the one sentence message from this talk, is that if you're not operationally perfect on security, then you need something like TUF. You need something that doesn't put all your eggs in one basket, that doesn't assume you're going to be perfect and then fail horribly if you ever make a mistake. Okay, and TUF was designed to expressly protect against situations where you would make, it's meant to allow you to have errors and make mistakes and still recover in a good way, and also have it where when you've made a mistake, it's not necessarily fatal, even when some bad thing, like let's say if Docker Hub, for instance, were to happen to get compromised. It's not the end of the world for everyone who's going and using that to store their container images. All right, so the way that this works with TUF is by using 5 different principles. I'm going to just kind of quickly go through these. I'm happy to go in more detail about any of this, if there's interest in this. But I just want to give kind of an overview so you get some of the high-level ideas about why TUF itself might work. Although this is not a deep dive, and we're not going to be going in and looking at exact metadata files, and I'm not going to be talking about what a lot of these boxes here mean other than at a very high level. Okay, so one of the first and primary design principles of TUF is to have separation of duties. So the idea is that you might have different parties that have different keys and have different responsibilities and different abilities to do things. So for example, I have someone who manages my grants at the university, and they have access to a bunch of like financial information, not just from my grants, but for other grants that they manage, okay? Yet I have access to things that they don't have access to. Like, for instance, if I teach a class, I have access to grades and whatever else. And of course, we have some overlapping access at times in that role. So it isn't that there's necessarily a strict hierarchy of things, but there's the ability for people to have different roles and to fulfill different roles. Another example of this is that an administrative assistant who helps me out has a key to be able to get into my office, as does a janitor who's able to go and get into every office, but the janitor doesn't have access to get into my desk drawer, which is locked, or other things like that. So you can see that you have different ways of doing this. Another property that TUF has is TUF has the ability to have threshold signatures. And the easiest analogy to think of is a real-world analogy with this. So when they have nuclear submarines and they want to be able to launch the missiles, what happens is that there's two keys that are very far apart in the submarine that have to be turned at the same time. And so this makes it so that one person who goes crazy and steals keys and does whatever else can't cause the nuclear warheads to be launched, right? So in TUF, you can have a similar thing where you can say, for instance, I can go and say, well, of the TUF maintainers, 2 of the 5 of us have to sign off on a release of TUF in order for that release to be considered a valid release. So I could sign with Marina, we could have Santiago and Lucas, or other developers of ours go and sign it and do this, but you have to have a threshold. One of us can't just go crazy and say, aha, this crypto miner is now the new version of TUF. Okay, one thing that I think we did very well inside of TUF is from the outset, our goal was to deal with and protect against compromises and to worry about people breaking into the system. That was the goal when building TUF. And if you compare this to systems like GPG, or you look at the whole like X509 architecture, I don't think anyone here would look at those and say they were clearly designed with revocation and trust removal as a first-class problem that they wanted to solve. They were very clearly, I think, bolted on later and do not fit very well in what they have designed. So with TUF, there's actually different ways that trust revocation happens in the system. And because of this, and because of the way that we really made this a first-class primitive, it's so natural and so easy to do that we've actually had a lot of people want to copy and use like effectively TUF's trust revocation in other domains. All right, so another thing we did in the design of TUF is when you're trying to protect a system, there's a couple ways you can protect it. One of which is that you can make it so that when bad things happen, they're less bad, which is one of the things we try to do in TUF. But the other is you can make it so that bad things are going to be a lot less frequent. It's going to be a lot harder for a bad thing to occur. So TUF uses both of those things together. And one of the things that it does is it makes it so that there's certain very sensitive roles in the system that have to do things. Like, for instance, serve as a root of trust, where there's a series of keys that may have to be used when you've had a serious compromise of a repository. So they probably only get used every 6 months or so in normal situations, but if you do have to pull them out, we want those keys to be able to be stored offline. They shouldn't have to live on a web server or something like that. So TUF very much supports and encourages you being able to have keys that are sensitive be things like YubiKeys or be things that are kept in safety deposit boxes or safes or desk drawers or things rather than just scattered around a bunch of computers connected to the internet. All right, and finally, one of the things that happens in TUF is because of our use of something called delegations, which I'm not going to go into a lot of detail. I'm just going to give you kind of a feeling about what it does for you, is that in TUF, if you're using TUF correctly, you should never, ever need to share keys. So imagine that Bob here is responsible for building the Windows version of some project. I don't know, some fun software project he likes. And some intern comes and wants to work with him, and the intern is a super excited Windows ME diehard user. So Bob knows he has 5 people who want the Windows ME version, so he's like, okay, intern, I'm going to let you be able to go and start signing the ME version. So the way you would do this if, for instance, you're doing this in a more traditional GPG signed way that Linux distros do, is that they would add the intern's key to the keyring for the distribution, and then the intern could sign everything, including like the Linux kernel for that distribution, even if they're only distributing the Windows ME variant of. This has gotten weird because we're no longer in Linux distribution land, but even if the intern is doing like Polish language translation for whatever, then their key would be trusted for everything. And so by the other option is that Bob just goes and gives the intern his key, which would also be terrible. So both of those situations are really bad, and yes, can lead to all kinds of problems when something goes wrong. All right, So in TUF, what happens is that in TUF, the intern can have their own key. And Bob can say, hey, you as an intern, you're able to do the things I can do, but only in this way, only for this specific thing. Like you can only sign a release of Windows ME. You're not trusted to sign the Windows 2000 release, which has 50 users instead of 5 that the Windows ME release has, or certainly not the Windows 10 release that might be used by millions of people. So, okay, so does everybody get the concept of delegations? Great, because now I'm going to show you an instance of delegation in practice. So I'm going to delegate the rest of the speaking in this talk to Marina, who's going to take over for me now. So Marina?
All right, thanks. So I'm going to talk a little bit about what you would do to set up TUF in your infrastructure. So if you wanted to use this in your system. So there's a couple of steps to get this done. You have to do a little bit of code on your client and on your repository, a couple of steps for developers, and then a little bit of extra setup. So what does this look like? So on the client, you need to set up an initial root of trust. So TUF is based on the idea that the client has this initial public key for the root, and then that key can later be used to then verify updates. And there's a lot of different ways to get this key onto the client initially. You can use any public key infrastructure system that maybe your system already uses, or you can do a trust on first use when the client first installs the software. Before any updates happen, they get this key as part of that installation. In addition, the client needs a verification step. They need to actually make sure they verify the TUF metadata to get all these protections. So they have to download the metadata and then verify it before installing the update to make sure that they don't install any malware. Then you have the repository, which basically just needs to generate your TUF metadata. This involves a couple of automated processes stored in the repository that need to be, like the code needs to be written for those and then set up. And then a little bit of manual initialization for these offline roles that can't be stored on the repository directly. So for these offline roles, you have your developers, who you need to set up that delegation chain initially. So your delegation chain for your organization will probably look a little bit like your org chart. Like you'll have, maybe your head engineer is your first, like the root of the delegation, and then they'll delegate to the heads of various projects, who maybe will delegate to their team members, depending on which parts of the project they're responsible for. And then you also have the root keys, which these are those offline keys that you want to make sure are very secure. And so when you first set them up, you want to make sure that you have, in separate locations, maybe even around the world, that you have developers. You can have different root keys stored in those locations. And you have to have kind of an initial key ceremony to make sure that those keys can be used to sign your initial root metadata, which will then be used to distribute updates. So there's a really good example of what a deployment looks like in practice. For PyPI. This is an ongoing deployment, but it's just a very well-documented example of how this process will happen. And so there's PEP 458, which is kind of a more basic implementation of TUF, and then PEP 480, which is kind of the full implementation. And these just provide a lot of details about what you would need to do if you wanted to do this on your system. Okay, so you have your initial setup done. So what do you need to do to maintain your system? There's pretty much just two things you have to do. You have to have your developer sign update and do a little bit of root key management. Everything else should be automated and shouldn't really need to be managed. So for the developer side, developers need to use those keys that they were delegated to sign updates. This is really similar to any other process that needs to have signatures. So if you have like Git code signing or anything else that uses GPG keys, this is a very similar process, and you can use any infrastructure you already have, like any YubiKeys that developers already have access to. In addition, you need to maintain that chain of developers to make sure that the keys aren't shared, and that if a new developer joins the team, either their key is delegated to, or if a developer leaves the team, that key no longer has access to the system, etc. And then you have a little bit of root key management. So this should only happen, this shouldn't be a big overhead, but the root key will expire after some period of time. We usually recommend like about 6 months or a year, depending on your use case. And then when that key expires, you have to go find those offline keys and use them to sign a new offline keys, which will then continue the chain of trust. Also, if there is a major compromise, these offline root keys can be used to recover from the compromise. So you want to make sure you have access to them in the event of a compromise. So this is the maintenance you don't have to do. It's basically all the other parts of TUF. So the repository actions are completely automated. So after your signed code is uploaded, the repository will automatically do the other signing, and then that'll be sent to the client who will automatically do the verification. So this, you really, after you first set it up, you don't really have to worry about this part. So once you have this all in place, you get a lot of security guarantees. And so this is kind of shows if you're able to install malicious update if any of these things are compromised. So as you can see, a root key compromise is very bad. That's kind of the main problematic one on this chart. However, less than a threshold of root keys is not as much of a problem. So what this means is that you want to make sure that your root key threshold is large enough that you never get to that bottom row. You only ever get to that row one up, and then you're able to revoke those compromised keys. In addition, if both your repository and a developer are compromised, an attacker would be able to install malicious updates, but only for that developer's project, and then the root role could go in and revoke those keys after some amount of time. So that's all the things that TUF does protect you against. These are some things that are kind of out of scope of the project or some things that we leave flexible. So TUF does not do supply chain security. So TUF kind of manages the part after your code is already finished. So you already built your code, it's ready to be sent to your customers. So from there to the client, that's the part that TUF manages. Like all the stages before that are just kind of out of scope of the project. And there are a lot of other really good projects that you can look at, such as in Toto or other projects for the rest of the supply chain. TUF also doesn't manage that initial root of trust. And I touched on this a little bit earlier, but you have to have some other way to get that initial root public key to the clients. And TUF also doesn't force any deployment decisions. So we have a reference implementation of TUF that provides a lot of this functionality. But if you have, for your system, you have specific requirements, you could design a version of TUF to meet those requirements. For example, the reference implementation uses JSON metadata formats, but if for some reason you have other metadata formats that would work better for your system, you can still use this. You can still use TUF with using those metadata formats. In addition, your key storage and thresholds are up to you and any trade-offs that your organization wants to make. So TUF is used in production by a lot of different people. We have a bunch of different deployments. So we have our reference implementation deployment, which is used by some people. Notary is a implementation of TUF, which is used by another group of people. And then Google, Amazon, and Flynn each have their own implementation. And Updane is actually a car variant of TUF, which is used by a lot of other organizations in the automotive space. So what can you do if you want to get involved in this project? So we have a Python reference implementation, which I mentioned earlier, and we're definitely looking for contributors or anyone who's interested in getting involved in that. In addition, Notary is an implementation, which I think is written in Go, and that also is available on GitHub if you want to contribute and become a part of that project. Or if you want to add TUF to your project, if you provide updates to people and you want to make sure that they're secure, you can add TUF and talk to us about how to get that going. So yeah, thank you, and let us know if you have any questions.
All right, who wants to kick us off? Small group, I know it's intimidating to ask the first question. Yes?
Are there any obvious integrations for TUF that you think should be worked on?
So, sorry, I'm going to try to repeat the question, but I only heard part of it, so when I trail off, that's it's you to shout. So how many, something about which integration should be worked on for TUF?
Yeah, so you
Okay.
said, add TUF to your project, but in the spirit of open source,
Yeah.
Okay, so really anywhere where you're trying to deliver software that you want to make sure that software was not tampered with. Sorry, let me repeat the question. So when and where should you deploy TUF? Anywhere where you're trying to distribute software and you don't want that software to be tampered with, you know, that would be bad. You should be using TUF is really the answer. Even in cases where, you know, and this is outside the cloud native space too. Like we have integrations and there's, you know, work with a bunch of other communities. Python was mentioned, but there's, you know, a bunch of other large communities like that that are doing work to integrate TUF. This really is, I believe we're the only system that's open that provides any kind of compromise resilience. And I've done work under NDA with some very large companies that also use basically what is TUF with slight changes to it to fit their environment. So this is definitely what you should be doing instead of TLS or GPG, because once again, if somebody breaks into your server or breaks into your build system, that's how your logo ends up on the first quiz slide that I had. And nobody wants that. Definitely your users don't want that. Yes?
So you mentioned promotes sharing or having distributed secrets. So if we talk about having our artifacts using Notary for certifying, so in terms of deploying them, maybe you call it AWS regions, if we deploy to different regions, should we use different engines to certify them so that if compromise happens, it would just be limited to one region?
Okay, so I think the question you're asking is more of a Docker secrets question. I think what you're asking is that should you deal with secret management in a different way in different AWS regions, for instance, in case you have a compromise so that information doesn't flow. To answer your question first directly, let me say I didn't directly work on Docker secrets or a lot of the other like HashiCorp Vault or the other competitors to it. So I believe there is some value in what you say, but I'm not really an expert. I will say from the standpoint of TUF, what the client has is it has public keys for the repositories and things it's going to be communicating with. So from that standpoint, it's not like the client has any sensitive key material like, private repository key or something like that on it. So from the client's perspective, there's in TUF, there isn't really a reason to do something different from the TUF side there. Yes?
So you mentioned Docker secrets and Vault. How does the TUF framework differ from what those projects offer?
Okay, so how does TUF differ from Docker secrets, Vault, and other things like that? So they do secret management. So they're meant to do things like, for instance, make sure that you don't type in passwords and private keys for encrypted databases and stuff like that. That information securely gets to your containers and is provisioned. TUF is making sure that the actual software that gets there is like the actual image that you get wasn't tampered with. Okay, so like Vault and other things like this are protecting secret data. TUF is not protecting secret data, it's bootstrapping your software, which is usually public data that you're gonna go, like your software images. So there's no Vault, there's no unsealing, there's no anything like that you would typically have in those cases. And there's also no real compromise resilience in the same way, because it's like a different space. Yes, in the back.
So I understand that TUF is about ensuring that the client gets what he's expected to get, right? But maybe it's outside the scope of TUF, but does it allow you to securely add additional metadata to the software packages? So what the use cases I'm thinking of are things like ensuring that only less builds can reach a certain stage in the pipeline, and how can we cryptographically ensure that only something that's been through integration goes to production?
That's a great question. And that's a perfect question to ask in the TUF/Intoto deep dive, because that talk, which is tomorrow at 11, is all about one of the integrations. We'll talk about like an integration of TUF with a project called Intoto. And Intoto takes information much earlier in your process, usually starting at your version control system, and carries all the build and CI/CD and other things like that in. And then that actually gets bundled up in some instances, at least, inside of the TUF metadata, and then is used by clients to do exactly what you're describing, which is to make sure this doesn't happen. And this whole sort of pipeline is actually already being used today in production by thousands of companies. And so is kind of ready, off the shelf with a couple different implementations and integrations. Although I think we're going to be focusing on the Debian one in the talk, but we can also tell you there's a lot of public information about the large Datadog integration and others like that do this in the cloud native space. Yes, there's another question, I think. Oh, that was your question. Yes.
So you mentioned PyPI. So are there other package managers, either at the system or language level, that people are, you're talking to about using this?
Are there other package managers, perhaps at the language level or the OS level, that we're talking to about using this? The thing about the open source community is you're always talking to everybody, whether you mean to or not. So we are having discussions, and we have had discussions. Actually, Aptium, Jest, and Pacman all use a security design that I did as part of my dissertation work, right? So we've had a lot of those engagements, and in fact, what was interesting is our discussions with PyPI took place like 6-7 years ago or something like that. We standardized some of the things we wanted to do through the PEP process, and then Docker saw this and got very interested and just kind of picked it up and ran with it. Because a lot of people heard about it in part through people in the Ruby community that were very interested in using it. So the community is all very connected, and yes, there's a lot of interest, but it's also one of these things that we found that until the thing is in production, you often get like the checks in the mail kind of as you talk to people about how they're going with their integration. So I don't want to count any chickens, but yes, there are things that are definitely in motion, and code is happening. In fact, Amazon just about a week ago released an open source implementation of TUF and Rust. So and we had no idea it was coming. So.
Is it connected to Cargo, or is it just an implementation?
I will know more about that tomorrow. So. You have to catch up with some of the people. So there's some people that were in the know that are like kind of in the Notary project and things, but in the core of TUF, because TUF itself is a spec too that a lot of people implement, that we encourage that to happen. And so as a result, the information doesn't necessarily flow all the way back to us very quickly, if at all. So yes.
Seems like an arrangement, but what do you think of enforcing TUF verification on admission control using tools like Portieres or things like that?
Yeah, what do we think about enforcing TUF on admission control? Yeah, I think that's great. I think it's you obviously having better integration into TUF to check and verify that things are being done in the right way. It really just protects you. I mean, it protects you so that you don't run into situations where, so yeah, one thing Marina said that I just want to kind of reiterate to kind of answer this question is that TUF is basically completely silent to your users unless something terrible has happened. And then they get this error and it says, hey, something, like this signature doesn't match anymore. What's going on here? Looks like someone might have hacked Docker Hub or something like that, And that's exactly what I think you want to do. And so doing those checks in the right places for your environment is really critical. And even further, to do an even better job of this, you want to go and do things like in Toto that integrate earlier in your supply chain and carry even more information through, which is what we're seeing a lot of groups do. Yes?
Does TUF make any assumptions or any statements about the metadata itself, or is it really just I need a link or a hash or something like that for metadata and I'm just dealing with something?
Okay, does TUF make any assumptions about the metadata itself, or does it just take a link? So I'm not sure I'm able to tease apart what you're getting at with your question.
I think basically he's asking, like, are there requirements for the metadata? And I think the answer is yes. There's certain fields that we require as part of TUF to be part of the different metadata files. Oops. Sorry. Okay. And then those required fields are then used as part of the verification process. And you can add your own custom fields if you have additional things you need to check.
So it basically does have a metadata structure in there. It's not relying on other metadata stores like GriphAS or something.
Oh, I see. I get more of your question now. Okay. So TUF in its metadata basically says something like this object with this sort of name, you can think of it, which is something that then whatever tool you're using to actually do the request and do the, do the actual installation can go and request that object, which in many cases is like a URL or something, like go get this thing. And then it has something like a secure hash, so something it can check for that object that it gets back. There are other fields that are optional that you can put, there's like the ability to put whatever metadata you want there. It's not like an opinionated structured thing like you would find in Grapheus or SPDX or software bill of materials or whatever, where you have to have like these 17 fields that indicate all this type of provenance and whatever else. Because that differs wildly by different domains and use cases and so on. But TUF has space for you to put whatever you want. For instance, in toto metadata as, or in the case of the large automotive companies that are using it, they go and they insert a bunch of information about like which VIN and which ECU serial numbers and other things like that this specific update would apply to. Yes, did you have a question?
It's more of a general one, not technical on purpose. So in a highly regulated industry, in finance, could you speak a little bit to the level of regulatory understanding that might exist in any group, particularly OCC and others, around TUF? And the context for my question is we would look at stuff like this, and yes, we're going to we have to also think about how we educate the regulators and the level of effort to do that, because we're adopting new technology frameworks themselves.
Okay, so there's a lot in that question, and I'll try to rephrase it in a way that I can actually answer it as well. Okay, so it was a good question, but there's some parts I'm going to kind of duck a little bit here. Have you spoken with regulators in different agencies about this? What's their view on something like TUF? How do they perceive it? Are there, is it something where you've gotten some folks to bless it and then, right? And we have done that in some areas. We have been more focused because the TUF variant Optane is actually used by major OEMs in the United States, multiple major OEMs in the United States, multiple major OEMs in Japan, and multiple major OEMs in Europe. So they're very aware of it, and we've also made strides with many other communities. There are folks specifically in finance, since you brought up finance as part of your question, that are using TUF in different ways. We would be happy to engage with regulators and do things like this. TUF is by the way, there's not a company directly backing TUF. Like I make $0 for every TUF install and everything with it. There's no like paid subscription plan for whatever or anything else happening. I'm a university professor, right? So the goal is to make the world a better place, and finance is an important place to make better. And so if we need to spend time talking to regulators, well, NYU's in New York. There's an awful lot of finance happening around there. I go to DC a lot too. Happy to talk with people and happy to do what I can to educate. Yes?
This is maybe more hypothetical, but from application, would this be useful or is there a better tool? In the same industry, you've been a regulated company, so some of the things we look for is the ability to do countersigning of third-party packages.
I love this question. Oh, great, I love this question. So you're asking, being in finance, you often want to do things like countersign, like have third-party also additionally sign information. One of the nice things about TUF is it supports thresholds. And with thresholds, you can say, this package has to be signed by our security team and by the external vendor who's supposed to provide it. Or you can do other things and say, like, our security team has the ability to block any package, but doesn't have the ability to go and immediately bless a package that wasn't otherwise provided, and so on. There's all sorts of little things that, despite the primitives in TUF being deceptively simple, you can do really powerful things, like exactly what you describe. And in fact, in the automotive industry, the way they deploy and use TUF, or the TUF variant Optane, is they actually have two repositories that they run in parallel. One that contains a list of all of the updates that should be allowable to be installed, and one that, but it's like signing keys and things are offline, like all the sensitive keys are offline. And then another one which says, you should install these updates. And this one has a sensitive key online because it needs to, like, reactively immediately make decisions because the OEM, the automaker decides for the vehicle what to install, right? And this combination and this like threshold delegation between them has meant that even if a nation state actor goes and becomes a man in the middle, breaks into their server with the online key, or and steals all of the keys on it, some of which right, would be protected, and breaks into the vehicle's network through something like their infotainment unit, then the damage they can cause is something like saying that there hasn't been an update for the last week when there has been one. In addition to that, they also have to go and break in and steal either the root signing keys or break in and steal offline keys for the other server, which are often located around the world, which starts to sound a lot more like Ocean's 11 or something than even what these very talented nation state actors are able to do. So, okay, any other questions? All right, well, we're going to have a deep dive, TUF, and you'll learn a little more about In-Toto talk at 11 o'clock tomorrow. And we'll also be around here if you want to stop off after the talk and have any questions. So one more round of applause for Marina.
Thank you, Dustin.
Yeah.